So we left off here last time where we have the different colors of our discs and stuff like that. And what we need to build today is the mechanic for moving a disc from one tower to another tower. That make sense? So in order to do that, we need to keep track of, well, we want to look at the different ways of moving objects on the screen. Okay, different ways of animating things on the screen. To start messing with this, I'm actually going to go to our scenes. Let me go back one here. And I'm going to add a new scene. Okay, so this scene that we're adding is just going to be a little practice scene. So something we can throw an object on and move it around the screen. That kind of stuff. Okay? Looking at the different ways of moving things. All right, so I'm just going to create a quick little actor here that we're going to use to move around the screen. All right? So this guy looks like this. All right. Now, we're going to look at our behaviors. We can accelerate something. So let's start off with that. The different ways of moving stuff. So we can accelerate something in a direction at a speed. We've seen this before. This is a cumulative type thing. So we're going to have this guy go to the right at an acceleration of 100. Except we're on the wrong scene. And we see he's speeding up. Starts off at 0, then goes to 100 every game loop. Okay? That's acceleration. What's the difference between that and accelerate toward? Accelerate toward, instead of picking an angular direction, we get to pick a position. So perhaps our guy starts off here, and let me just kind of throw him down here and see what his current XY is. 445, 100. Let's say that. So we'll go back into the actor. Well, actually, let me, so I don't forget. Oh. Put him back up there. We're going to have him accelerate towards 445, 100 relative to the scene. Okay? At a speed of 100. We see him flying towards that position. Okay? Now he kept going, so he didn't stop at that position. Oh, he hit the end of the world and bounced off. Okay? So at all times, his acceleration is going to be taking him towards that position. So that allows us to bypass things like angles. You know, we could have done the math, right? Where we built the upside, you know, it would be a right triangle, but we would have built the triangle to figure out what that angle is that he needs to accelerate at, or on the trajectory to get to that point, to intersect with that point. Okay? Well, we can also, so this guy does that math for us. So the first one, the first behavior, accelerate, gives us a speed and a direction at an angle to accelerate. And then it even gives us a little commentary. So specify the speed and direction angle of acceleration of an actor. Best use in a rule that checks for a keyboard event. Note, if the drag behavior is not also applied to an actor, acceleration will be continuously applied. So it just keeps loading up unless you have a behavior associated with drag that slows it down. All right, so that's the difference between accelerate towards and accelerate. Okay, let's see. Animate. Animates doesn't move an actor, it animates pictures within an actor. Okay, we'll mess with that, so we'll eventually do like a little Mario-looking dude, and we'll have like 4 pictures that kind of show the different leg positions, and then we'll see that's animating, and it looks like Mario's running. Okay, let's see. Change velocity. Change velocity would be a static value. You pick your direction as an angle, and you pick a speed. So we'll have this guy go to the right at a speed of 100, and he takes off. Constant speed. Okay. Acceleration uses the physics engine to build up. Change velocity just says you're setting cruise control. Okay? Interpolate, this you can actually use this to move a guy, but interpolate lets you change the rotation of something. It messes with a matrix, so it allows you to change rotation, position, and what's the third thing it lets you do? Oh, scale, size of it. Okay. Here's some interesting ones. Move and move to. We'll go into this actor. Let's look at move. Move says move in a direction relative to the actor, so we'll still go to the right. Now, when you can either adjust the angle directly here, or you can twist this, or if you hold shift, it goes in 45-degree increments. We'll just go to the right like before, again relative to the actor rather than the scene. And the movement type, we have additive or stacked. Let's look at the difference between these two. We'll go at a speed of 100, so we have everything the same as we've been doing. Constant speed. Change it to stacked. Any difference? Look the same to me. Oh, sorry. Let's have him move relative to the scene. No difference? Additive. Okay. I don't see any difference between additive and stacked. So it remains to be seen what that guy does.
Might it have to do with having multiple moves?
Multiple what?
With multiple move behaviors? Potentially.
I understand. So what if, let's try this. Let's try to move him to the right, and let's try, I think you're correct, is my guess at this point. So we're going to have him move to the right, additive, and we're also going to have him move down at a speed 100. So let's do this additive, and let's see what behavior that gets. And let's do it relative to the actor in both cases. Okay, so both are happening at the same time. So that gives our 45-degree angle. So that's equivalent to us picking that point down here and saying go there. Okay, so we can do that with two moves in a row. Now let's try doing this as stacked and see if we get a different behavior. We do. Okay? So, what's happening is, and I wonder how to get something off the stack. A stack, so I'll pretend like I happened on purpose because it's actually very related to what we're talking about here. What you'll learn about in the 300 class. So, not next semester, but next spring, a year from now when you take that programming class. We teach things in there called data structures. And one of the data structures we look at is something called a stack. In Towers of Hanoi, each tower is a stack. Okay, so think of a stack as a stack of magazines. We all know what those are. It's a last in, first out queue. So the last magazine we put on the stack is the first magazine we take off the stack. So whatever is our last movement behavior that we put onto the stack, that's the guy that's currently getting focus. That's what it appears to me. So that means, since I put this guy onto the stack first, move to the right, and I put this guy on the stack second, move down, the move down is the guy that's taking precedence right now because they're stacked. So I suspect that if I change the order of these guys, move down first, then pushed on top of that, stacks support 3 functions. Push, pop, and peek. Push says add something to the stack. Pop says remove something from the stack. Peek says just look at the top of the stack. Okay? And we write that programmatically in the 300 class, but the programming behind that is actually quite simple. It's utilizing those 3 functions to solve problems where the complexity is. Just like a hammer isn't anything complex, right? It's a heavy piece of metal on top of a stick. But we use hammers in interesting ways to solve interesting problems. Okay, so I switched the order here. So we're going to go down first, and then we're putting on top of that, we're pushing on top of the stack the move to the right. So my belief is that, the idea of being stacked, since this guy's most recent movement is to go to the right, this guy should go to the right. Okay, so that doesn't mean that he's not still trying to go down. At some point, he needs to stop moving to the right. So what's interesting there, how can we simulate that? Let's do this. Let's do a timer. And let's do something for 3 seconds. What are we going to do? We're going to move down for 3 seconds. Well, hold on. I'm doing this backwards. We're going to do this first. We're going to move down for 3 seconds, which... No, I want it the other way. I want it the other way. I want it like that. So we're going to tell it to start moving to the right. But then we push on top of that this behavior of move down. But this is only going to go on for 3 seconds. At the end of 3 seconds, this move behavior should end. Therefore, I believe it should get removed from the stack. So when it gets removed from the stack, it should then free it up to move to the right. So we're going to see if timers indeed remove stuff from the stack. But essentially what we're doing is we're saying, move to the right, now immediately start moving down. But stack it so we're no longer moving to the right. This guy's still sitting down here waiting to become the top of the stack again. For 3 seconds, the move down is the top of the stack. Then, I hope that the timer kills it. This guy's no longer on the stack. This guy's now the new top of the stack, and we start moving to the right. So we'll see if that's the behavior we get. Otherwise, we need to figure out how do we change the order of something on the stack. Did 3 seconds go by? Or did it go off the screen before 3? Let's just do it for 1 second. Okay, it killed it. All right, so as soon as that timer ends, the behaviors inside of it die. That's a scope. So these guys, this behavior has a local scope. That is a scope to the timer. So its context is the timer. That's the world it lives in. And when this timer ends and the world is destroyed, all the variables and behaviors that live inside that end. Therefore, this guy is removed from the stack, leaving the only thing left on the stack to go to the right. That makes sense? So, interesting way to pull off those types of moves. Now, would you say a move along those lines is kind of what we're looking for our, well, think about it for a second. Let's go back to the previous scene. When we say move from this stack to this stack, might we want something to go like, here, over, down? That's at least a reasonable solution to the problem, right? Okay, so is this the way we can accomplish that? Is this a way we can accomplish that?
Yeah.
Sure. It's probably a too complex way to accomplish it. Because couldn't we say move here, then move here, then move here? Or move here, then move here. Those are all things we can do, right? Well, how do we say move to here, and when you get there, move to here? We just pulled it off there with time, correct? So let's go back into our actor. So one thing we could do is we could finagle with it, where we say, okay, well, we're going to have this guy go up here, and it takes about 0.63 seconds for him to clear the top of the tower, only if he's the top disc. If he's the second disc, and it's 0.71 seconds. If he's the bottom disc, it's 0.83 seconds. Don't ask me why it wasn't consistent. You were using the stopwatch. Okay? So we're all basing that on time. So we're going to move here for so long. Then we stop moving. Then we can move here for so long. Well, that's always going to take the same amount of time, right? Now, how many of you believe that the speed that something will move on my screen is equivalent to the speed that something will move on your screen if you're using Game Salad? My feeling is that's probably true. Game Salad likely uses a game loop based on an actual time unit. Okay, so realistically, this might be okay to do in Game Salad. But we have an issue. I think I maybe used the example here previously. I tell you about the Double Dragon video game I had for my PC. It used to run on DOS. Yeah. Okay, and it had, you could tell that the timers for it, for moving around and stuff like that, were all based on what are called busy wait loops. Basically, they just had random timers in there and it says, wait for 3 seconds. Well, what's 3 seconds? Well, it's about 2,000 times through a for loop. Well, 2,000 times through a for loop back in 1996 was a lot longer than 2,000 times through a for loop today, because our processors are a lot faster today. So when I got a more modern computer, nowhere near what we have today. Basically, when I got something equivalent to like today's toaster, okay, which was a much more modern computer than the Cinder Block that was the previous computer. It was a Cinder Block with a screen and a disk drive. That's what ran Double Dragon the best. Okay, I needed the correct speed slow computer, but it was fast computer back then. You get it? Okay. So when I ran it on a more modern computer, the game was unplayable. These guys were just zipping around the screen. It was like Halo on steroids, and Halo goes too quick for me. They have to put me on, what is it, the God mode, where I just keep coming back to life. That way I never run out of ammo. I just try to shoot everybody, and then somebody kills me when I run out of ammo. That gets me new ammo, because I'm not good at moving around to go and find new ammo. You know what I'm saying, right? Okay, so in any case, would it be smart, even though we predict with Game Salad that the speed is probably controlled on time units, would it be smart for us to do our animation based on a timing? Like, okay, well, it takes us this long to float up to here, then this long to float over to here, and then this long to float down where we're supposed to go. Maybe not what we're looking for, right? Okay. Could make it work, but might have future problems. In the brand new iPhone 6 that's going to be, whatever times faster than the current one and 9 times the screen size and blah, blah, blah. We might want our game, and these people are going to pay $50 for this game. Well, $49.99. I think Apple doesn't let you set like round numbers. So $50-ish for our game. We get to keep 70% of that. That's not a bad cut. Every one of us gets like a penny and a half or something. Yeah, we're good. It's set. So in any case, and we'll clearly sell at least 1 million copies. We don't need 1 million people emailing us screaming that, whoa, wait a minute, the disk is going too high or too far, and the game still plays logically right, but it looks all messed up because it's not even sitting on a tower. Because it flew for a second, and in a second it flew farther than it used to. The computer's faster. Okay, so maybe that's a little dangerous.
Just have to tell them wait for a patch.
Wait for a patch, right?
$2.99
Yeah, $2.99 for the upgrade. It's the sequel.
Yeah.
Actually, that was really what happened when iPhone went from iPhone 3GS to the iPhone 4, which was the transition between the standard display and the Retina display. You had a bunch of people re-release the identical games as blah HD. Buy it all again. It's just everything reskinned, the same exact game with the higher definition graphics or whatever.
Yeah.
People bought it. Plants vs. Zombies was like a huge hit. It was the same game. Then they released it for iPad. Plants vs. Zombies HD iPad. It's the same game, just on a bigger screen. And the resolution on the iPhone 4 is actually very similar to the resolution on the iPad before Retina display.
Yeah.
Man, consumers don't know this stuff, just get ripped off. I knew it, and I still bought it. I wanted to play Plants vs. Zombies on the iPad. I needed something to do at church. Well, I mean, if you're at church, I mean, you're giving the glory to God. You don't need zombies attacking in the middle of church. So I was protecting the other parishioners. Okay. So in any case, we can make it look right by moving to a position, then moving to another position, but it might not be good to do that on time. We'd rather say, I want to move here. And once you reach this spot, don't move in this direction anymore.
Right.
Then move here. And once you reach this spot, don't move again. Then go down. Okay? So we're going to come over here to our practice scene. We're like at the gym, and we're like a gymnast, and we're working on the move that we're going to use in the competition. Okay? But, you don't want to do this in public. It's not game time yet. It's, let's see if we can get this guy to do the behavior we want. So we're going to start him. There we go. I need a little bit. It's the shakes, plus the malaria. Every day I keep getting better.
That's good.
Yeah, finally went to Solly's this morning, so I had to replace some of my my newfound red blood cells with butter.
If you do give the malaria to me, I will not be very happy, and I will expect an A.
I'll think it's hilarious. You'll probably get your A. Not if you die though. If you die, then do you have an iPad?
No.
You probably have a cello or something. I don't want that.
I've got 5 bass guitars.
Yeah, it doesn't do anything for me. What do you have of geek value?
It's about a mid-level gaming rig.
Okay, so garbage.
Pretty much.
Yeah. All right, then don't die. Because I won't know what to scavenge, is what I'm saying.
It all goes to my brother anyway. He wouldn't get it.
He gets free tuition.
Is that really a rule?
Feel better.
What?
That sounds made up.
No, if your roommate dies, you get free tuition.
You get free tuition.
That's like morbid that it's a rule. Okay, is that really in print somewhere, or is this like one of these things that everybody just says? We assume it's true. Somewhere in print, it says if your roommate dies, you get free tuition. I don't believe that.
I've never heard that.
I don't believe that.
I heard it's only if you commit suicide in the room.
Okay, but
At least some schools have that as so a lot of schools have that as a policy because they want you to come back.
yeah, no, I mean the point is,
I don't know if we do.
I can see that being an unwritten rule.
Yeah.
That is part of the healing process the university happens to extend that offer to the grieving people. I can't imagine them putting that in writing.
No, not
It's like, look, if you can somehow off your roommate and not get caught, it's a good way to lower your long-term debt.
Well, they never say they pay what's already taken.
It's like in the small print in the financial aid packet.
It has to be like accidental that there can't be murder or something.
You're talking to the financial aid officer. You're like, yeah, I mean. No, I think he's just down there yelling at his own. So, anyways, he does that. It's fine. It's normal. He does it every semester, so this must be that lecture. So, in any case, you're talking to the financial aid officer. You're like, yeah, I'm just not getting enough this semester. I'm not going to be able to go. He says, okay, well. How well do you know your roommate? Tell me about him. Tell me a little about him. I know a guy.
I watched First 48.
Then go and watch the movie. What is it? Horrible Bosses. You can go and go and meet the guy. They teach you all about where to go and find the guy to help you. The guy has a very funny name.
Ask Siri.
Yeah.
Ask Siri.
But you need to watch it on the, you can't watch it on like TBS where they, they just change his name to something not nearly as funny. Okay, so we need to get our guy to go up, then over, then down, without using timers.
You can drag and drop it, or do it manually.
Okay, we don't want to do that. No, but I totally agree. We can certainly do that. We can, in fact, let's just do that real quick to show our last way of moving.
Dragon.
Do we have change position? Or do we have to just change those attributes?
Couldn't you move it based on XY position?
That's what we're going to do. But I thought that there's a thing to just specifically move to a position.
Well, there's the move to.
Right, but what we want to do based on, we want to do this. We want to create a rule. The rule's going to say this actor receives touch pressed. So we're like holding on him. Okay, receives touch pressed. What are we going to do? We're going to take our actor's position on X. We're just going to drag him to the right, let's just say. And set it to our actor's position on X plus 2.
You're not going to really see that.
Or you could just constrain it to the mouse.
Sure, we can do that too. Okay, so this will give us a consistent movement, but not necessarily related to where our the mouse is. So that's when we're pressing it, then when that event fires. What he wants to do is he wants to go into this actor, and he wants to just constrain.
That's change.
Oh, thank you. I said the right thing. I got malaria. He wants to constrain an attribute. Which attribute? Our actor's position on X to whatever our mouse's position on X is. So this is the first time we've used. I need to go back one here. This section for devices. So under devices, we have mouse, we have touches, we can deal with the accelerometer, we can deal with the screen from size, orientation, like we want to know it should look one way when it's landscape versus portrait, blah, blah, blah. Audio, as well as the current clock. So this is how we can access a timer. Go ahead.
Is there any way you can bind like the different towers to like a key? So like you could just move it from W to S or SD.
You tell me. How would you do that?
I don't know. Can you?
Don't those just sound like variables to me? To you?
Is there a way to access the keyboard?
Okay, hold on. You're saying a key on the keyboard.
Yeah.
Okay, when you first said, I was thinking like related to a variable. You're thinking more like the W movement. Like W is going up,
Yeah.
and then D is going to the right.
Like just to a certain tower, like move to, like you click on the ring and then you say move to W is the first tower, or.
Right. So I was thinking you could do that as variables.
Okay.
You could also constrain it to the position of one of those towers. But I see what you're saying. You want to do it based on a button on the keyboard.
Yeah.
So think of our dude on the disk becomes our dude. Okay, when we click on our source tower, that the guy at the top of that source tower becomes our character, and we can press W to move him up, then R to move him, or D to move him to the right, This is along the lines of what you were saying, right? And then, S to make him go down onto the tower that you ultimately select or something like that.
I think the other one he was getting at was using like a key for a tower. So you click at this, and then you hit a key. And it goes
Right.
to that.
There is a way you can deal with the keyboard, but I think it's an event. I'm going to create a rule. Actor key. Actor receives a key press from the keyboard. So you can do it based on a rule. Okay, so we're going to constrain the attribute, this particular actor's X position, to the device's mouse position on X. Perfect.
Oops.
Okay. All right, so that's a good way to move stuff.
You put it in a rule for when it's pressed and it just does that?
Well, hold on a second. So this one I'm doing right here. This is one of the major mechanics of creating one of the most famous games in history.
Pong.
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 Yep.
Well, Breakout too. But even before that, you had Pong. Pong is amongst the best-selling games in history. You know that?
Mm-hmm.
It's very interesting. And how long would it take us to write Pong?
10 seconds.
Well, more than 10 seconds, but not long. Certainly we can do Pong in a class period or two, right?
Right.
I mean, basically you just need to make everything bounce off walls. And bounce off your paddle, whatever this is. And the physics engine would take over the rest. That's Pong.
The hardest part would be the computer.
The AI.
Oh, to make the guy on the top move right?
Do that. Play against yourself.
Yeah, just give yourself, it's like the ping pong, like give yourself the wall up here.
Yeah.
See how many you can hit back and forth until you miss? Then it's like Flappy Birds. That's it. We're going to bring back Pong.
Faster and faster.
The next big thing.
We're going to bring back Pong. So maybe that comes after Towers of Hanoi, because Towers of Hanoi is obviously going to be a hit. Okay. You don't think so? There's actually plenty of Towers of Hanoi apps on the App Store and they're all free. I think anybody who
penny and a half.
Well, maybe in the bootleg community. People pay big bucks for bad games that get pulled off the App Store. I think. What am I talking about? Oh. So that's how we can constrain it to a mouse movement. But we want this guy to go up, then over, then down, based on some anchor points. Okay, so go back into this actor. The first place we want him to go is, let's say, here. So we want his Y to move to 190, let's say. Whatever he currently is, we want his Y to move to 190. Okay, well, I can say change attribute, actor's position on Y to 190. And then when we start the game, he'll just immediately move. Not what we're looking for. We need him to move as a result of something. Okay, fine. We'll do this as a result of something. So we'll create a rule. Actor receives event, touch pressed. So only when we click him will he go to 190. Also not what we want. We want to see him lift off the ground like a spaceship to get to position 190. All right. Well, so we want to see him move at a speed to that point. What do you think?
Can we do a rule and say like accelerate toward like if it is less than that value, then you can accelerate towards it. But then if it equals
Okay.
it, then you have to.
Well, if you accelerate, wouldn't it move past? You'd want it to move to that position.
Well, two things together. So he said if we click, you want it to start accelerating to that point. Okay? So we're going to accelerate toward.
Oh, you can do that too.
You want to do that? Okay.
Doesn't matter.
Well, yeah, the difference will be whether or not it speeds up on the way there or just goes there at a speed. Fine. So other than the problem solving of it is identical. So we'll do move towards. We're going to move towards what position? This particular actor's X and a Y of 190. Yeah, we're changing the Y, but we'll just, so wherever he's currently at on the screen, make him go up to 190.
Right.
Okay, we'll do this at a speed of 100. Click him. I have to hold it for the event to occur, but that's not important for what we're trying to do right now. So you click and hold, and as long as that event's firing, it moves to 190, and once it hits 190, it stops. Okay. Now, let me go back in here. Once we're at 190, where do we want to move next? Let's say we want to move here. Just coming up with our values here. So an X of 280. Move to position 280. And we'll say whatever this guy's Y is. We know it's 190. Well, we want it to be 190, but
If we decide to change our minds.
well, this will allow us to see what the result's going to be the first time through here. It's not going to be what we're looking for. Well, ish. Okay, so now when we press it, we're going to go up to 190, and we want to go over to 280. But we want to see it go up to here, and once it hits here, go over to here. That's the behavior we want to see. Why did move to work that way?
The one ended.
It's telling you to move to a certain spot, and then it's going to stay there.
Is move to stacked? How do you know it's not stacked? If it was stacked, it would have done the move to the right first. Correct? This guy blocks. He finishes before this guy starts. Now notice you have these things in here called run to completion. That's if these guys are in separate threads. They're across two timers. You might have to force this behavior of letting one finish before another one begins. You may actually not be able to force it if they're both in different timers and they're both run to completion. Because then it's a matter of who interrupts who first. So you might get them happening in the wrong order, but regardless, this move to blocks this guy. So this guy doesn't start until this one finishes. Does that make sense? So it allows us to do this behavior and then that behavior. Similarly, where's this guy start? He's starting at X of 127. Finally, we can do a move to X of, no, sorry. I don't want the X. Yeah, I need to go look up what the other X was.
The Y was.
Yeah. In my mind, what I said is what I don't mean, because I just clicked on the
Do as you say.
89. I want to set Y to 89. And I want to set X to whatever X currently is. That's what's about to happen. What did I say, 89?
Yeah.
And then X is whatever it currently is. We could have left it at 300 for a turbo landing. Let's do that. So that's what aliens would do, right? You know, all those, isn't that what all the video show? It shows like these lights in the sky and all of a sudden it zips off?
Something like that.
Yeah, see? I watch, was it the Sci-Fi Channel?
What is that?
They found
Lifting?
Bigfoot 2 weeks ago, you know that?
Wouldn't the one lifting be the one that's really quick?
That was just me walking around. Are you sure it wasn't an April Fool's joke?
No, there's actually a whole series, I think, called Squatch.
It's Finding Bigfoot.
Oh, it's a Finding
Yeah.
Bigfoot. The guys refer to them, them as Squatches.
Is that
Yeah, I know. I find those things fascinating.
If you ever go out west and you're in the mountains or the hills, watch out for those guys. They're creepy.
What, the Squatches themselves or the guys looking for
Guys
Squatch?
looking for them. I had some random guy like walk up to my car and like a big old Bowie knife on his side and stuff.
Man, that's the kind of guy you have dinner with around a campfire. That's a story you'll never forget.
Started hearing banjos.
Oh, I mean, I'm like dead serious. If my wife wasn't there, because my wife, she's a lot different than me. I'm kind of a freak show. Well, like it even starts with this. I always wanted to be a storm chaser. I wanted to chase tornadoes. I think that would be awesome.
It is fun.
Okay, but my wife is like literally phobic of storms. Like you have like a severe thunderstorm watch. You know, like when it's like not that big of a deal.
Right.
When she gets one of those, we're in the basement with the cats.
Just get one of those armored cars.
So, I don't know. Okay. That guy's become famous.
My
He
brother
was-
actually saw him down in Indy.
He was on Mythbusters.
Yep.
They put that car and another one of the Storm Chasers,
Tiv 2.
cars behind the 747 jet engine.
Mm.
Oh, hold on. What just happened?
It went.
That's an interesting behavior.
Should we put that?
Let's set it at 100 just to make sure that's some sort of weird stacking thing.
Is it?
You have to put that in
You
a
want to
different
set
timer
it
or a
to
different.
when touches release?
Well, no, I mean we could. That would make this. Well, actually, it still wouldn't work because touches released would be firing off the bat. Let me set all these to run to completion. It might just block one.
Yeah, is it?
It's actually very freaky.
Because you said
Move it outside of the loop. Oh no, that would. It might do it.
No, you shouldn't. I mean, you shouldn't have to. Is the
Right.
point?
Josh
Is it
says
combining?
you were setting the X. No, is that because it's going from the X in the beginning and skipping the other ones?
Oh yeah, 2x.
Okay, so if I hard code that to 280, you think it works?
Nope. Interesting. Did we find another bug in game set?
No. Let me add one more move to here. Let's have this guy go to 489.
just reading whichever one's left.
All right, extra credit if you can figure out why that's doing that. Next class. That's supposed to work as a linear, not additive, but a linear list of moves.